NASA has made an amazing discovery on Saturn's icy moon Enceladus. They have discovered that the moon is ejecting phosphorus, one of the key chemical elements required for the existence of life. And possibly, the concentration of phosphorus in Enceladus' subsurface oceans is hundreds of times greater than in Earth's oceans. With this, all the major chemical elements necessary to affirm habitability have been found on the moon. This discovery has made Enceladus the most promising place where life could exist in the solar system, beyond Earth. So how did NASA make this exciting discovery? Why is phosphorus considered a key ingredient of life? Finally, and most importantly, how will this discovery affect our future missions to Saturn? Enceladus, Saturn's sixth largest moon, was first discovered by William Herschel in 1789. However, our knowledge of it remained limited until Voyager 1 and Voyager 2 passed close to Saturn in 1980 and 1981, providing some insights. But it wasn't until the Cassini probe began close flights of Enceladus in 2005 that we truly discovered its captivating surface and environment, bringing it into the spotlight. Despite being only about 1/7 the size of Earth's moon, Enceladus displays a wide range of features, including ancient heavily cratered regions and young, tectonically deformed terrains. However, there was much more to discover. Contrary to what was initially thought about its cold and inactive nature, Enceladus surprised scientists by revealing a subsurface ocean beneath its icy crust. Not only that, but water from this hidden ocean was observed emerging through cracks, creating powerful jets of water. These jets are thought to be caused by gravitational forces exerted on the moon by Saturn, which in turn heats Enceladus' rocky interior. As a result, pressurized water gushes out through cracks in the ice, propelling itself into space at tremendous speeds. These geysers release frozen water particles and gas at speeds of approximately 400 meters per second, equivalent to filling an Olympic-sized swimming pool in just a couple of hours. While much of the material falls back as snow on the moon's surface, some of the jets contribute to the creation of a plume that feeds Saturn's faint ring, located beyond its brighter main rings. During its flyby of the ringed world from 2004 to 2017, Cassini flew through the plume and the E-ring several times. In doing so, it was struck by these particles that came from inside Enceladus. And so, by following and analyzing the data collected by Cassini, scientists were introduced to the spectacular chemistry that the moon harbors beneath its deceptively calm, white surface. The moon's ice grains were recorded to contain a rich variety of minerals and organic compounds, most prominently the presence of the ingredients that form the basis of amino acids, which in turn are the building blocks of life. As we know it, a promise of chemistry. Analysis of Enceladus's ice grains over the years revealed concentrations of carbon, hydrogen, and nitrogen, with a tentative detection of sulfur as well. Some simulations also suggested that the subsurface ocean might be moderately alkaline. All these factors favor habitable conditions. However, there was a key item missing from the ingredient list to assert a possibility of habitability. And that key ingredient was phosphorus. Although it is the least abundant of all the essential elements required for biological processes, it plays a critical role in paving the way for life to thrive. For example, it is one of the building blocks of DNA, which makes up chromosomes and carries genetic information. On Earth, it is present in the bones of mammals, cell membranes, and the phytoplankton that inhabit the oceans. But not only that, phosphorus is also a fundamental part of the energy-carrying molecules present in all life forms found on Earth. In short, life would not be possible without phosphorus. Until now, this critical element has not been detected in an ocean beyond Earth. In a recent study using data collected by Cassini's Cosmic Dust Analyzer, or CDA, between 2004 and 2008, scientists have made an exciting discovery: the presence of phosphorus in Enceladus ocean. Surprisingly, the detected amounts of phosphorus exceeded previous expectations. This valuable information was obtained from mass spectrum analysis of more than 300 grains of ice from the E-ring. When a dust particle impacts the dust analyzer sensor, its trajectory determines whether it hits the central rhodium target known as the target chemistry analyzer or CAT, the surrounding gold target, or the inner wall of the instrument. If a dust particle impacts the CAT with enough energy, it vaporizes and becomes partially ionized. This creates an impact plasma composed of ions from the target and particle, as well as electrons, neutral molecules, and atoms. The instrument then separates the plasma components and analyzes the resulting mass spectrum of the ions produced by the impacting dust particle. By examining the mass spectra, scientists can gather information about the mass and relative abundance of fragmented ions, allowing them to deduce the structural features of the original molecule or element that impacted the dust analyzer. In the case of CDA massed spectra of E-ring grains sampled by the Cassini spacecraft, the presence of sodium phosphates was revealed, indicating the detection of phosphorus. Enceladus is alive. The results obtained by Cassini were confirmed by laboratory experiments on Earth. Now the question arises, where does this phosphor come from? On Earth, phosphorus is released into the environment through weathering and weathering of terrestrial rocks. However, Enceladus lacks such geological processes. This has led scientists to propose that interactions between the Moon's ocean water and the rocks that form its core may result in the dissolution of significant amounts of phosphorus into the ocean. Phosphates have been commonly found in comets, so it would not be surprising if the rocks that make up Enceladus's core contain phosphates. What is remarkable, however, is the fact that these phosphates are dissolving in the Moon's subsurface ocean, providing the missing ingredient for the potential development of life in this environment. While having these ingredients is a necessary condition for life to exist, they may not be the only requirements for a potentially life-supporting extraterrestrial environment. Therefore, whether Enceladus ocean can be a suitable habitat for life remains an unanswered question today. To explore and discover the answer to this intriguing question, future missions are needed to build on Cassini's incredible legacy. Recently, astronomers made a groundbreaking discovery. Finally, they detected the background of gravitational waves, or the hum of the cosmos. It is a significant discovery that may open doors to new physics. So if you missed this episode, be sure to catch up on this fascinating find.